Today we're looking at the distributive property. Yesterday we looked at 4 different properties, and we had one lesson dedicated to those 4. Today we have a full lesson dedicated to the distributive property. That's how important this one is. This one is the usefulness of distributive property ranges from like, oh, it helps me to use mental math better, to I better know what I'm doing because I need this for this specific problem. So you're going to need to understand the distributive property. And so let me go ahead and give it to you, and then we'll explain it, and then we'll start using some examples like how do you even use it. Okay, here's a distributive property using symbols. Okay, A times B plus C is equal to, so go ahead and write that down. So if you have a number multiplying a sum, okay, this is a number multiplying a sum, and this can be 2 addends, 3 addends, it doesn't matter. You can rewrite that AB plus AC. So write that down. Maybe some of you are looking at it saying, what in the world did he just write down? We'll talk about it. We'll use examples. Will help us to see what's going on. Okay? All right, so this is your beginning statement. A, and you can read this a couple ways, A times the quantity of B plus C, or you can read it A times the sum of B plus C. Does that make sense, the words I'm using? And then this is read equals AB plus AC. Okay? So how many of you can kind of see what I'm writing up here so far? Maybe you can't explain it to me, but you kind of get what I'm trying to write up here. Okay? Maybe just a few of you. All right, let's use some numbers to help figure it out. All right, look at on page 27, example number 1. Okay, so I'm going to use this property here, and this is example 1. And what did they tell us to do in example number 1? What are the instructions? Yes, sir. Braden?
Find 14 times 12 mentally using the distributive property.
Okay, first they say find 14 times 12. And how do they want you to do it? Mentally. So you're supposed to work this out, like stack them together, start multiplying? No. They want you to do it mentally. Now, I've told you already, guys, I struggle with mental math, but that's why we go over the distributive property, because it's going to make it easier to do in your head. Okay? Which is nice. I think it's nice. Okay. Using what property? The distributive property. Okay. So everyone see what I have right here? Okay, this is what I'm going to do. I'm going to rewrite this, okay? And this is part of your homework. They're going to say rewrite this. So please watch what I do. I'm going to keep the first number, in this case 14, the same. And then I'm going to ask you guys a question. 14 times 12. Yes. Oh, you already know what to do?
I know what to do.
Go ahead, Braden. Yeah, I'll give you guys a chance.
You do 10 plus 2.
Okay, hold on, Brady. Before we keep going here, I'm confused. The problem was 14 times 12. So how in the world did we get 14? Somebody else. How did I get 14 times 10 plus 2? What? Who came up with that? Yes, ma'am?
10 plus 2 equals 12.
Oh yeah. 10 plus 2 is 12. So did I change the problem? No, same problem. It's written differently, though. This is where I'm getting confused if I'm not careful. But everyone okay? Everyone okay with this being the same as that? Okay, now this is where we're starting to use the distributive property. How would I write that using 2 products? So 2 multiplication problems now. I thought there's only 1. There's 2. Michael?
Actually, I have a question.
Yeah, go ahead.
Does it have to be the 14 that stay the same, or can you do both?
You could have done 12 and then break this down, for example, 10 and 4. Yep. And you could break this down into anything. Break that down into anything that equals 12. You can do 6 and 6, totally okay. Okay, go ahead, John.
You could do 14 times 10 plus 14 times 2 equals 10.
Oh, okay. Okay, so anyone know what 14 times 10 is? Everyone should. I hope you guys can get these quickly. Boom, add that 0, you're done. And then what's 14 times 2? 28, good. That's not too bad. I mean, maybe it takes you a little bit of thought, but not too bad. And then what do you do with those two numbers? Add them up. So what's 140 plus 28? 168. All right, how many of you do this to multiply double-digit numbers? How many of you do that already on your own? You prefer that? Okay, how many of you do not prefer this? Okay, I'm going to tell you guys right now who do not prefer it that you're using this process anyway. Ready? All right, so maybe some of you are saying, I like this way, Mr. A, right? Isn't that the preferred way? All right, so let's go ahead and do it. What's 4 times 2? Bless you, 8. What's 2 times 1? 2. Okay, and then we do that place value. I do a 0. Or 1 times 4? 4. And then 1 times 1? 1. Then what do you do with those two? Add them, get your 168. Does anyone see it?
Yeah.
Okay, where did I get the 28? It's right there. Where did I get the 140? Right there. What did I do with those two? Added them. And what did I get? Same answer. You've used a distributive property ever since you've had this type of problem, which was a long time ago, right? Distributive property is valuable, or I would say invaluable, because it has a value that we don't even always recognize, and yet you use it all the time. I want us to get used to writing it like this, and I like some of you who are thinking, can you break this number down? Yeah. Can you break this into something else? Yep. As long as you're following the rules, as long as you're not changing the problem, you should be fine. Okay, let's have you guys do some practice problems. On page 28, I want you to look at number 5. And before you start working it out, guys, I want you to do this. Do me a favor here. Do yourself a favor. Read the instructions. So someone want to read that out loud, nice and clearly? Yes, ma'am? For number 5, go ahead.
Restate each expression using the distributive property. Do not simplify.
Do not simplify. Okay? Do not simplify. Just rewrite it using the distributive property. So this is number 5. You can go ahead and do it if you feel comfortable. If you're not comfortable, I'll do it here on the board with you. So 5 times 7 plus 8. So that's the problem. That's what they give me. I want to rewrite it using the distributive property. So this is what they mean. Well, doesn't 5 get multiplied by 7? So I just write that down. 5 times 7. Okay? And then I'm also going to multiply 5 by 8. And that's just written 5 times 8. And then what do I do with those two products? I add them. That's rewriting it. Ta-da! That's it. That's the answer to 5. You get what they're asking for? They just want you to be able to go from this expression to this expression right here. That's it. How many of you maybe aren't comfortable doing that? Are not comfortable doing that? Okay. I'm going to give all of you practice, even those who maybe not as comfortable. Go ahead and do it for number 6. You do it on your own. Number 6. Rewrite using the distributive property. Do not simplify, please. Okay, who can give me the first part? So what would be your first part? Don't give me it all. Caroline?
6 times 2.
6 times 2. Okay, so who can give me the second part? Emma Grace?
6 times 4.
6 times 4. And what do you do with those two? Sophie? Add them. That's it. Do not simplify. Could you simplify? If I told you to do it? When it says to simplify, do it. When it says do not simplify, don't do it. Mr. A, I simplified it because I thought that's what you wanted me to do. No, the instructions were clear. Okay, but look at number 7 and gasp. What's different about number 7 and all the other 3 examples we worked on so far? Marissa? Oh my goodness, a variable. Okay, sorry, I got caught up again. It has a variable, and variables are mean, right? They're just these letters that were thrown into math. What's a variable stand for?
All numbers.
It can, or it stands for a number, right? So do I treat it differently than I would the other numbers? No. So let's see if you can try number 7. I want to see if you can handle a variable in that expression. So do number 7 on your own. And then in just a moment, I'll have somebody help me out on what to do on 4 times a quantity, x plus 3. Is okay? Doing all right? Okay. Question or answer? Okay. Someone give me the first part. Elizabeth?
You do 4 times x.
4 times x is the first part. All right, second part. Josie? 4 times 3. What's going on between them? Michael? Adam. Ta-da! You are done. Okay, Bella. Yeah, go ahead.
What about if you put 4 times x in parentheses, then the addition, and then...
So you did parentheses here and parentheses there, and then the little symbol. You could, I mean, that's technically okay. I'm fine with that. Just make sure you put the symbol of multiplication there, and then 4x together, 4 first, then x. That's all right. Okay. Did anything change much on that problem? It wasn't that much harder. Now, let's look at this one and see how would I simplify it. Okay, so here's the answer to number 7, but now I'm extending the problem. How would it become simplified? I want it simpler. Okay, yes, Elizabeth?
It would be 4x plus 12.
4x plus 12. You guys okay with that? Good on that? That's it. Can I combine these two together?
Yes. Yes.
I hear no and yes. So
Yes.
Yes.
yes, no, yes, no. Okay, here's the next part of our lesson. So I'm getting into the next part here. There are 2 quantities that are called terms. So go ahead and write here 2 terms. The first term is 4x. The second term is 12. 2 terms. Terms are separated by addition. Okay? Terms are separated by addition. So what I want you to do is I want you to look at the first term and the second term. Can I combine them was a question that I asked. Most of you said no. Some of you said yes. We got to clarify it. Well, are these 2 like terms? Like terms. So let me give you a definition here. Like terms. This is super important. I love this idea because if you understand it, you can simplify without going too far. Because if you go too far, you get a wrong answer. Like terms. Terms that have the same variable with the same exponent. Terms that have the same variable with the same exponent. This is what happened last year teaching 7th grade. I remember December, before Christmas break, I brought up the idea of terms, and I changed it a little bit, made it look a little bit different. I'm not doing that to you right now. But I remember in December, we were going through a little exercise. They were going through their papers, and they were struggling. They're like, I don't get this. Some of them, I get it, but a lot of them, I don't get this. Mr. A, what are you doing? Okay, and so we struggled in December. You know, by the end of the year, no one struggled anymore. Do you know why that happened? What do you think happened between December and May? What happened?
Since you started it so early, they had time to practice it, and then they just practiced and practiced without letting it.
Yeah, some, and different rates. Some got it a month after, 2 months after, at the very end. The thing is, these like terms, I want you to get down as soon as you can, but if you don't fully understand, don't feel bad, okay? I don't want you to feel like, I don't get this idea. I'm going to try to drill it and bring it up and try to show where you can see it in different problems. But don't be afraid to do this. Mr. A, I'm not sure, how did you find those terms? What are those terms? How can I find the terms? Whatever the question is, please ask. But everyone has this definition down? Okay, ready guys? How many terms did we say were up here?
2.
Okay, looking at this term and this term, do they have the same variable in each term? The answer is no. You can no longer combine them anymore. They're done. That's as far as you go. Okay? You're done. All right. So let's look at example 3. Look at example 3. This is where we're gonna skip to. We're going to example 3. This is where it plays into what you're doing. All right. Can someone read me that problem? Sophie, read me the instructions.
Simplify each expression.
Okay. So we have two of them, A and B. Simplify. Make it simple. And Sophie, go ahead and read for me A.
679p plus 1,999p.
199p. All right. Can anyone tell me how many terms are in this expression? Tristan? 2. First term, second term. You guys see it? What's separating them? Addition. And let me help you out. It's going to be addition or subtraction, but later on, not too long from now, this is the cool part. We're going to tie addition and subtraction together. They're all just a big fat addition problem. You see those subtraction signs in all your problems? It's actually addition. And you're like, wait, let me restate that. Swivl, get this. You see all those subtraction signs you have in your problems? They're actually addition problems.
Because they can cancel out.
Possibly. Possibly. Yeah. We'll get to that. Not yet. Don't be too scared right now. Okay. Do you guys see this right here? These are like terms. Why would I call them like terms? Because they have 9s in them? I don't. What's the definition of a like term? Or why are they like terms? Answer that question. Jensen?
Because they both have P as a variable.
They both have the same variable, don't they? They both have the letter P. The second part of your definition to the same and the same exponents, we're going to leave that for later on. This is P to the first, an implied one, and that's P to the first, an implied one. So these are like terms. So we can actually do what with those two terms? Combine them. Okay, this is what I want you to think of. I'm going to show you what's going up here on in my head so that you can understand what's going on. Okay, I'm going to use the distributive property here. Ready? Okay, what do they both have in common? What's a common thing that they both have? And don't say 9. It's not 9. It's something we just talked about. Yes, ma'am.
The variable.
They have the same variable. Ready, guys? I'm going to rewrite this. Done, done, done. Okay, ready, guys? How in the world did I do this process? Okay, what did we say they both have in common? They both have a P. I took that out. I factored it out, okay? And we'll get more into those details later. And then you see what's left in the parentheses still being added? Okay, is this expression and this expression the same thing?
Yes.
Okay, you're going to have to be able to take this expression and rewrite it like this. Okay, that's part of your homework. You think you could do that? No? Okay, we'll get some practice. But now, here, what do I have to do with these two numbers? Add them. So this one you could do in your head. I mean, you technically could do it in your head, but let's just do it on your paper, 679. Oh, that's not pretty. Now, what I noticed in your homework that I'm going to pass back to you in a little bit, your 2 assignments, the last 2 assignments, show me more work, some of you. Some of you are doing great with your work. Step, 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 answer, right or wrong. At least you showed me your steps. And some of you are like, answer, sometimes right, sometimes wrong. The only problem is I have no idea why you got it wrong. No clue. You have no clue. So that's not very helpful. All right, here we go. 9 plus 9.
18.
Oh, 18. 9 plus 1 plus 7. 17. 1 plus 9 plus 6. 16. And then 1 plus 1, 2. Okay, ready? So this is what I'm left with. P times 2, 6, 7, 8. Is that how I normally write those answers down, you think? Is that how I should write it? Is that how it is simplified? Is that what we are trying to teach you here? Okay, how do I rewrite this to make it proper? Caroline?
Can you go 2,678?
Yes. Ta-da! That's what I do. That's how I write it. That's the answer. This is not wrong, as in it's not incorrect. It's the same thing as that, but it's the proper way to write it. Yes, ma'am?
Okay, I just have a random question.
Random question.
Well, it kind of has to do with this, but the variables, can you do two variables? So like, instead of having just P, doing like two P's or like P and a J or something?
Okay, good. If you combine like terms, they have to have the same variable or variables to the same exponent. So if they both have, like, say, PJ and PJ, you can combine them.
Okay.
Yeah. Yeah, PJ. PB and J will also work. All right, here's another one. This is a cool problem. It's very helpful for us. X plus 12x. So that's B. Okay. How many terms are here? Two. You guys see it right here and here? Okay, good. If you can identify terms, that's good. That's a good thing. I want to use the distributive property here, but I'm stuck. Isn't there usually a number in front of the variable? But here there's no number. Or is there? Okay. I want you to think, hold on, of the identity property of multiplication. Okay, think of the identity. Anyone know what that was? Identity property of multiplication. What was that? Bella?
I don't know,
Anybody here? What's the identity property of multiplication? I know they know. Yes, ma'am?
you can add or multiply 0 by any number.
You can multiply any number by 1 and get the same number, right? Ready, guys? So, look at this. This is my cloud of thought. Ta-da. My cloud... Swivl. Are you playing a prank on me? Okay. X is equal to 1x. Is that true?
Yes.
Okay, what's 1 times x? X. So can you technically write a 1 next to that variable? Okay, and now I can use the distributive property. Okay, guys, this is what you're going to have to be able to do. You now see the number in the variable, right? What do they both have in common? They have both in common the letter X. So that's going to go outside the parentheses, right? And then you're going to have something in the parentheses. Well, what should go in there?
1 plus 12.
Yeah, this number and that number. It's like they got left behind, but they're still in the parentheses. Would these two expressions be equivalent? That means would they be the same value?
Yes.
Yeah. Can you maybe do that and turn it into this? Okay, let's try it out. On page 28, try out number 10. Try out number 10. On page 28, number 10. I first want you just to rewrite it. Just rewrite it. Don't simplify it if you can't. Just rewrite it like I did right here. And then we'll go further. So number, what did I say, 10 on page 28? Okay. Okay, hold on, guys, hold on. Yeah. Oh, yeah, what's the number in front here? 1. Are these like terms?
Yes.
Can we use the distributive property then?
Yes.
All right. John, keep going. What do I do?
You do X on the outside of the parentheses, and inside you do 1 plus 9.
Ta-da, that's rewriting it. Guys get that? That's how you rewrite it. Now, if it says on example 10, or number 10, it says simplify, you got to go one step further. So how would this simplify? How would it become as simple as possible? Michael.
It would be 1 plus 9, which 1 times 9.
Or, sorry, 1 plus 9? Mm-hmm.
Which is 10, and it's just 10x.
Yeah, you'd get your 10x. That would be your final answer. Okay, do you guys understand the difference between rewriting and then simplifying? You should be, listen, this is what I want you to do. Please listen. You should be able to go from this to this and this to that. Back and forth. That's rewriting. And then when it says to simplify, you go from here down here. Good on that? Okay, let me give you your homework. I'm going to have to switch something up because time is running out. So I'm going to change it on Sycamore. That happens a lot. Just forgive me. All right. It's going to be 15. Oh, man. I'm going to give you 15 to 23 all. It was going to be 15 to 35 with some of them taken away, but I'm just going to go 15 to 23 all. 15 to 23 all. Yeah, 15 all the way to 23. Page 28. 15 to 23, page 28. Remember, don't tell them, guys, because I changed it up again.
Do they have to do 15 to?
They'll do the same thing you do. Yeah, 28. Oh, I really wish we had more time, guys, because we get into a good groove, but then we have to go. Then we have to go to break. Yes, ma'am?
Mr. A, you're still recording.
Oh my, Swivl, you stop that.